our last little prep before we start graphing is to talk about the domain and range of the 6 trig functions. And so we did the unit circle before because we're actually going to use the unit circle to kind of explain some of these. So the first thing we're going to look at, I'm going to actually come down here before I start filling in the table. What's important to remember is when you have your function f of x is equal to one of your 6 trig functions, you want to think about your input and your output. So the domain is the input, and what you're inputting are angles. And what you're outputting are ratios. Really important, especially when we're in a few weeks going to start inverses, because then it will switch. So we're inputting an angle, we're outputting a ratio. If we take a look at the unit circle, I'm going to pick a point anywhere on the unit circle here. And I'm going to call this A comma B. I don't want to call it XY because I don't want you to confuse it with the XY of the function. So the A comma B and then R is 1. So the first thing we're going to talk about is the domain and range of sine and cosine. So I'm going to label these points because we're going to use them. So this was 1 comma 0, 0 comma 1. Negative 1 comma 0, 0 comma negative 1. Okay, so when we're talking about domain and range of sine and cosine, so when I have sine of x in the unit circle, it's going to output the y coordinate of the unit circle, which is b. And when I do cosine of x, it's going to output the x coordinate of the unit circle, which is a. Again, it would be over r, but because we use the unit circle and it works out so nicely for us, r is 1. So any angle that you pick, right? So imagine that you start at 0 degrees here, and then you keep going around the circle. So you would do 0 degrees, and then you would do 360, and then you would do 720, and then you would do 1080, and you could literally just keep going around the circle. And you could go clockwise, so you could have negative angles. So because you can always go around the circle, you can always have an angle. You will always have an angle. Every angle will have a y coordinate. So no matter what angle you're looking at, right, you're always going to have an angle, and every angle is going to have a y coordinate, and every angle will have an x coordinate, because you're going to land somewhere on the circle. No matter how big or how small your angle is, you're always going to be on the circle. And on the circle, you always have an x and you always have a y. So because of that, every angle works for sine and cosine. And when you don't have any issues in your input, we say that the domain is all real numbers. We don't have no issues. So all real numbers, you can use the letter R, or you can use the interval notation. So you can always evaluate sine and cosine. Sine and cosine will always have an answer. It will be the y and it will be the x. Now, what are we going to output? So because, I love my colors, we're going to look at B first. We're going to look at sine. So sine is B here. So we want to look at what is the largest value you can output and what is the smallest value. So the largest value is going to happen up here at the top of the circle, and the smallest value is going to happen at the bottom, because the y is the coordinate that goes up and down. So the smallest sine you can ever output is negative 1. The largest you can ever output is 1. So the range is including, you use these brackets when you want to include, because they can be negative 1 and 1. So anything between negative 1 and 1. Remember that as a side note, sine is the opposite over the hypotenuse, and this will always be bigger. So it makes sense that sine cannot be bigger than 1. It's going to be impossible because the hypotenuse is always larger than the legs. And it's going to be negative 1 and 1 at the axis angles. And cosine works very similarly, but instead we're looking at the a coordinate. So the largest one would happen all the way on the right. The smallest one would happen all the way on the left. But for the exact same reasoning, the output, the range is negative 1 to 1. And again, for the very same reasoning, cosine is adjacent over hypotenuse, And the hypotenuse will always be bigger, so your ratio will always be less than 1. Okay, let's move on to tangent, secant, cosecant, and cotangent. I'm going to explain the domain for them, but I will not explain the range. So for the range, you will just have to memorize those. You can always ask, of course, but in the video, I will not explain. So the domain of tangent and secant. So tangent is sine over cosine. And in the unit circle, it's the y-coordinate over the x-coordinate. And secant is 1 over cosine, which is 1 over the x-coordinate. So what happens is when you have a fraction as an answer to a function, what can happen is that you need to look at the bottom of your fraction. So the reason that I'm doing tangent and secant together is because they both have the same denominator. They both have the denominator of cosine. And in a fraction, the bottom cannot be 0. So what you have is that you have that the cosine of x, which is equal to a, cannot be 0. So what we do is we look here and we say, what angles does this happen at? Well, the angles where cosine is 0, remember, it's the x-coordinate. So I'm going to do this, so lots of colors. I'm going to do this in pink. So what angles is cosine 0? Well, the x is 0 here and here. And that's the angle of pi over 2 and 3 pi over 2. So that means that x would equal to, and I'm going to make some room and you're going to see why, pi over 2 and 3 pi over 2. Now, of course, that's only one revolution. You can keep going around the circle over and over again. So you would add 2 pi. Now, 2 pi is 4 pi over 4. Oh, no, it's not. 4 pi over 2. So pi over 2 plus 4 pi over 2 is 5 pi over 2. Now, you could also do it from this one. So 3 pi over 2 plus 4 pi over 2 is 7 pi over 2. So that would be the second revolution. I could go into the third revolution. So 5 plus 4 is 9 pi over 2. 7 plus 4 is 11 pi over 2. And then you could keep adding 2 pi forever and ever and ever. But remember that you can also subtract 2 pi. You can go clockwise. So I'm going to do it to this one first. 3 pi over 2 minus 4 pi over 2 would be negative pi over 2. Pi over 2 now minus 4 pi over 2 would be negative 3 pi over 2. And you could keep doing this forever. So what we want to look at is we want to look at the pattern of these angles. So what do they all have? Well, for sure, they all have a denominator of 2. And at the top, they all have a pi. So what we want to look at is what's in the front of them. And what I notice is that in the front of all of them, negative 3, negative 1, 1, 3, 5, 7, 9, and 11, they're all odd numbers. These are odd. So these are the bad angles for tangent and secant. These are the ones that make them undefined. So this is x cannot be these angles. So the way, they can be anything but that. These are the ones that they can't be, but they can be anything else. So the way that we write that is that we write that it's all the real numbers except the bad angles, which are odd, and you call them multiples of pi over 2. The reason that you're calling multiples is because they're multiplying to pi over 2. You're taking the odd numbers and multiplying them, right? Negative 3 times pi over 2. Negative 1 times pi over 2. 1 times pi over 2, and so on. So again, you can make a little note. These are the bad angles. And secant is exactly the same because they both have cosine in the bottom. Okay, so why do you think we do cotangent and cosecant together? So now it's going to be very similar. I know that cotangent of x is cosine of x over sine of x, which is 1 over b. And I know that cosecant of x is 1 over sine of x, which is 1 over b. So we do them together. What color have I? Yellow. Because they both have sine. So now we have that sine of x, which is equal to the y coordinate of the unit circle, cannot be 0. And we ask ourselves, oh, actually, you know what? I'm going to do this. We were talking about sine using orange. So I'm going to use orange for sine. And then we're going to ask what angles. And that we're going to do in yellow. So if we go to the unit circle and we look at where the y coordinate is 0, that happens on the x-axis. So it happens here and it happens here. And that is angle pi and 0 and 360, so 0 or 2 pi. So I'm going to write those. So x is 0, pi, 2 pi. But you could keep adding 2 pi. So 0 plus 2 pi is 2 pi. Oh, I already have that. Pi plus 2 pi is 3 pi. 2 pi plus 3 pi is 2 pi plus 2 pi is 4 pi. 3 pi plus 2 pi is 5 pi, and so on. You could also subtract. So I could do pi minus 2 pi, which is negative pi. 0 minus 2 pi, which is negative 2 pi, and so on. So then we look at the patterns. So they definitely all have pi's. And then we look at the number in the front. And so it's 1, 2, 3, 4, 5, or negative 1, negative 2. It's even 0. That's how you're going to get 0. And so this is the odds and the evens. So it's all of them. It's all the multiples. So again, these are the bad angles. These are the ones we want to take out. So we go up here. So it's all reals except, and now it's every multiple. So multiple of pi. And you could write all multiples of pi if you feel like that's going to help you remember. So all reals except all multiple of pi, the evens and the odds. Okay, so let's talk about range. Again, I'm not going to go into a lot of details about this. I'm just going to tell you what they are. For tangent and cotangent, they have the same, and it's actually going to be all reals. So you can output any real number from tangent and cotangent. And that has to do with the fact of putting a number of negative 1 over 1 over negative 1 over 1. But it kind of goes into the notion of talking about limits, which is something you'll talk about in calculus. For secant and cosecant, because it's the reciprocal of sine and cosine, so you're going to switch the opposite and the hypotenuse, or the adjacent and the hypotenuse, it's the complete opposite of negative 1 to 1. So it's going to be negative infinity to negative 1, union 1 to infinity. The only time they have a similar ratio is at negative 1 and 1. Otherwise, it's the reciprocal. So negative 1, negative infinity to negative 1, union 1 to infinity. Okay, so here they are, and here is the explanation for where they came from. So it's really important to remember the domain and the range because we're going to be using all of this, graphing, taking inverses, doing word problems, and so on.